All right, so for our very first second this new year, right, or this new semester rather, we're going to go through everything for spherical geometry. So really, these two pages, pages 100 and 101, and we'll go over the notes in class, the examples in class. All right. So there's a difference between spherical geometry and what we've been learning about before, right? Every geometry we've done before in the past was called, it's kind we call it Euclidean, is all normal geometry, right? This is the normal stuff we've done before in the past, right? Like all the things you have to do with shapes and triangles, whatever, and all that. Whereas spherical has to do with all these different shapes and all these different things affected by if it's on, well, a sphere, right? So a 3D round circle and all that kind of stuff. So we have these before of points, great circles, lines, and line segments, and see how they're a little bit different now. But really, a lot of it has to do the same thing. To name a point, you just need a dot. It's a location um, made by a dot with a capital letter. All right, a location made by a dot with a capital letter. So in this case, right, so that's our location, that's our dot, right? So point, whoops, that looks terrible. Point A, or really, right, just right there, it's point A, something like that. That's simple, that's straightforward. All right. Circle. So great circle is a little bit different than what we got. So great circle is obviously it's a circle, but the way it kind of you've had this kind of definition already that you've kind of gone through is if you have to go, it's a circle that's made if you made like an intersection through a sphere, right, or through the middle of the sphere. So based on like this one point here, you have these great circles that are kind of going around. So for a great circle, um, all right, you name it by 2 points on the circle. So, right. So any circle you kind of make through this stuff, so it has to be on this. Like in this case, it'd be C and A. So we can call it circle CA, where this little thing indicates it's a circle. Okay. We also have lines in spherical geometry. Really, a line thing uh, as a great circle, right? These are actually one and the same, right? So in this case, right, you could still be like this whole thing CA, or if we were going to name it like a different one, like if we have 2 points on this circle back here, we can call it, oh no, EG, right? Or circle EG, right? We don't really call it, I mean, you could call it a line because it's still technically a line and goes around, but really it's better to call it a circle. It's kind of keep it the same consistency and all that, right? Because there's a difference actually with line segments, so we can actually see what that is. So for a line segment, all right, we talked about it. It's just an arc. The arc on a circle labeled uh, by endpoints. Right. So as opposed to like the whole thing, right? The line segment would just be from like C down to A. From E, you can see that they're arcs. It's a line on a circle, so it makes an arc. It's kind of weird, right? But in this case, we can still call it um, we'll introduce that kind of notation later. EG or CA, right? And that's the difference, because notice the different types of ones we're looking at. All right. So that's kind of what that is. All right. The main idea, and just kind of understanding what it looks like when we're seeing, we're not going to go through too much into it, because really what's important is like on this next page where we have like these postulates in this triangle sum theorem, where most of our ideas and most of the stuff we're going to go through and talk about have to do with these two instead. Okay. So the parallel postulate, right? Okay. The parallel postulate. So what's going on with this thing? Um, through a point not on a line. Let me zoom in. This one's a little bit harder to see. Through a point not on a line, there is no line parallel to the given line. There is no line parallel to the given line. All right. So this is kind of important, right? Why is there no such thing as parallel lines on the circle? So really what's happening, since lines are great circles, right, since they're actually circles themselves, right, they're always going to go all the way around, right? Because normally a line will go straight, and it goes on forever. But because it has to be on the surface of these two, the two lines will always intersect. In fact, any two lines on the sphere are going to intersect at 2 points. At 2 points, right? So not only is it going to hit it once, but because of how lines work, no matter how you draw them, right, you're always going to have some kind of intersection point. So, right, these two that we have that I can trace, obviously you show that they actually kind of work, right? I remember a circle, a line has to be a great circle, so it has to go all the way around. It has to be able to cut through it, right? So like technically, right, if you draw a line up here, this up here is actually not a line because it's not the full circle, it doesn't go all the way around. It has like a little piece of it, right? So that's a big indicator of what we're looking at. Okay. So, so since lines are great circles, um, two always intersect, right? That's all it says. Okay. This one up here is not a line because they have to be the full all amount, all that we're looking at. Even if you're going to draw like another one, right? Even if you draw one straight down, kind of going back up, right? Like it intersects here, there. They just have all these intersection points that we're like, what's going on with this? All right. So lines can never be parallel on spherical geometry because they're always going to be full circles. All right, the triangle sum theorem. We've kind of had one like this before. Uh, it's different normally, right? In a triangle, whenever you create a triangle on Euclidean geometry, normal geometry, right? They add up to 180. It doesn't when it's on a circle. It's kind of weird. It's you'll see. Let's talk about this. All right. The measures of the angles of a triangle again, this is all on a circle. This is spherical geometry. Oh, on the angles of a triangle is always greater than 180, but less than 540. Okay. So what you're looking for, right? The triangle itself, how much it actually is, it's going to be 80 degrees, right? We're talking about our triangle. So I'm gonna draw a triangle. And 540, right? So the number to make a triangle on these things, it has to be between these two. The angles have to add up between those two. Right. All right. Okay. A triangle in spherical geometry is formed by the intersection of three arcs that lie on circles. Triangle in spherical is formed by the intersection of three arcs that lie on different great circles. Separate great circles, different great circles. Yeah. Okay. Um, and then last, the sides of a triangle in spherical geometry are curved. Whoops, curved. That looks terrible. All right, that's all. Okay. So yeah, if we look at this stuff, right? If we're looking at this one triangle we have here, so again, triangle three sides to it. So we'll have one side, two sides, three sides. And so the way this works is, again, I mean, it's just like any other triangle if you add up three sides, right? So AB plus BC plus AC, right? Those all create this triangle right here, triangle ABC. So that means when you add up angle A, yeah, I'll call it angle A, angle B plus angle B plus angle C, right? They have to be either greater than 180 degrees or less than 540. So when you add these angles and they're not between these two numbers, then it's not going to work out. It's not going to be great. So again, when you add these three angles up, it has to be between these two numbers and then works out. And those are the two main ideas really we're talking about, right? So there's no parallel lines, and we have to try to create these triangles that actually bigger than 180. It's something different we talk about. This is the only time this works out. This is the only time we're going to talk about this throughout the whole year, so we'll be all right.